Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge. Second question. Basically, this is the question which was the previous question which we were doing. Here now the thing is that we are required to go ahead with some more refined constraint. So basically, in that context, the thing would be that here as the constraints are pretty much high, so accordingly we are required to go ahead with some optimized solution. So basically the question is same only, but now here we will be going ahead with the optimized version of the previous question. So now let us go ahead with the same. So first let us basically before coding the same, let me tell you that how I would be going ahead with the coding for the same. So see, here we are required to take three numbers, right? And these three numbers should be in that manner that we can maximize this, right? And for maximizing this, you can means you can clearly see a minute. And for maximizing this, right? This particular should be higher and this should be lower so that this whole sum is maximum, right? And even this multiplication factor, this should also be as much high as possible so that this overall value which is there, that is maximum, right? So in that context only, we will be going ahead with the solution. So we will be figuring out the candidate for this nums of I and nums of k, and this particular candidate for this would for checking the candidate for this particular, what we will be going ahead with, we will be directly just traversing this array, and for this we will be maintaining a prefix sum, not a prefix sum, basically the maximum prefix which is possible, and for this we will be going ahead and maintaining maximum suffix which could be possible. So these things which we will be maintaining here, and accordingly, and why we are doing so? We are doing so so that we can maximize this also and maximize this also. And this will be, as we will be traversing here, so accordingly whatever overall maximum we will be getting, so we will be choosing nums of z for that particular. So this is how we will be going ahead with this particular question, and this is what we are required to code it. You can either pause the video and code by yourself, and if you're like stuck somewhere, then yeah, you can then watch and go ahead with the same. So let us go ahead and code for the same. So here let us start. First thing, just for convenience, we are taking nums.size here only. So if our n is basically less than 3, but here we see that it is always this, right? So this check we are not required. So we will eradicate this check. Now, first thing we will be taking, because here the return type is long long, right? And we are dealing the sums and so on. So that's why from start only we will be going ahead that max value which is possible will initialize the 0, and then what is our max one? So for max one, we will be starting from a nums of 0, and then for the max two, we will be starting. Oh, I need to keep it. Okay, max two, we will be going ahead with nums one. So these two we will be going ahead and starting. And as I was saying you that we are required to take prefix and suffix max, right? So for that I will be taking two vectors. So long long end. So pref here, and here I'm initializing it with 0 and okay, this vector. Then for this long long end, and then suffix which is there. Minute. So uh, now we will be first. giving it size, and then we will be initializing it, and here also giving it size and initializing it. And then for static purpose, ref dot pushback, because it will be from the starting, right? So that's why pushing back with the number of 0. And for the suffix part, suffix dot pushback number of n minus 1, because we need to check from the last. Now we will be keeping the order the way we will be doing for prefix, like that only we will be doing for suffix as well. But for suffix we will be reversing the same just to make it convenient. That's why we are doing like this. So now first thing is that here int I equals rather than 0, we are required to start from 1, because our logic would be in that manner so that it won't give us TLE, not TLE, sorry, RLE, time error. And then if pref dot back, we will be checking that if pref dot back which is there, if it is less than nums of I, right? Then in that condition only, we will be pushing back the pref with our nums of I. Else pref would be pushed back with this pref dot back itself. Now the same thing we are required to go ahead with our suffix as well. So for suffix, as we are going ahead from the last one, right? So last n minus 1 we have already pushed into the same. So we need to go ahead with n minus 2, like greater than equal to 0, I minus minus. If now the same logic would be there. If suffix dot back is basically less than nums of I, then suffix dot push back nums of I, else suffix dot push back suffix dot back itself. Now we would be required to reverse this suffix, because the way we have pushed into the same, so in that context it won't give us desired result. So that's why we will be reversing suffix dot begin, comma, suffix dot end. So this all thing we have done, which is required, means basically the prerequisite part, means a prefix and suffix max we have calculated till now. Now comes our main part. So here is a thing which we are required to go ahead with. Int I equals to 1, I less than n minus 1, I plus plus. So here with this loop traversal, we will with this basically traversal, we will be easily able to get our candidate for nums of 2, means basically the second one which was there. So here int left, we will be taking at pref of I minus 1, and int right would be equals to sub of I plus 1. So here the max value which we are required to calculate, that would be maximum of Maxwell, comma, here we got discussed the same, and left left minus sums of I. And at the end, we would be required to return our Maxwell as that will give us answer. Mm. So let us check on example. One minute, somewhere I'm doing some mistake. So next, okay, basically these are also not required to us. Prefix and suffix is there and the same. In fact, next in number 5. Mm, Let me check it once. So here basically we just remove that initialization and the size which we were giving here, and then it got accepted. If you can run it, yeah, you can check it as it got accepted. Is the whole solution is the same as it is. So now comes the part for the time complexity in the space complexity for the same. So time complexity, you can clearly see this is order of n, this is also order of n, this is also order of n. Reversing takes log n, although, and there's in the space we are taking the suffix and prefix. So basically, the solution becomes the time complexity of n log n and the space complexity of order of n. So for this log n which is there, if we take suffix in some other manner, means the way now we are taking not in that manner, if we take it like in suffix of basically just by putting at the index, then we can simply remove this reverse, and then overall time complexity will become just order of n only, means then log n would also won't be required. So in that context, we can optimize this particular part, and then overall time complexity and space complexity will be this one. Means a solution from order of n cube, it has become now order of n solution. So basically, this was all for this particular question. If you are still in doubt, you could comment that down. And if you like the explanation, do like, share, and subscribe to my channel. So this was all. Thank you.